Good afternoon, ladies and gentlemen, and welcome to this web series brought to you by Spark Group in association with Scope T&M Private Limited. My name is Balasaheb Doifode. I am CEO, Scope T&M Private Limited. First and foremost, we are extremely grateful to you that you had chosen to take your time out and join us for this webinar series. I hope all of you and all your near and dear ones are safe. These uncertain times of Corona had brought many changes apart from turbulences in our life. One of the major changes that we had seen is the way we operate. Most of the things that we thought will be not happening online are getting shifted to online. Learning and knowledge sharing is one of them. First and foremost, let me be grateful to Mr. P.K. Patnaik, who has created this community of Spark Group, which has created a platform for us where we can reach out to large number of fellow industry colleagues when it comes to sharing of our knowledge and cumulative learning. It's this particular platform which has made it possible to bring this web series to you. Friends, Scope is not new to you. However, let me tell you that we are really humbled by the kind of response we had got. We had got 1,000 plus registrations for this session. In fact, for almost all the sessions. Now we are already joined by more than 430 people. And I'm sure in next 5 to 10 minutes, this number will practically go to a level of double of this. This shows us the kind of faith that you had shown on this Spark platform and on Scope as a company. We deeply appreciate that. Scope, is a pioneer in developing various solutions for different and difficult measurements. We had developed solutions for dynamic contact resistance measurement, surge arrestor leakage current measurement, which is the topic of the session today. And all this work we had done in collaboration with our customers, our fellow industry colleagues, that is all of you. We had chosen 7 topics for the next 7 days as a part of this webinar series in association with the Spark Group, where we are covering those important measurements which we believe, after getting the feedbacks from our industry colleagues, are of most importance to you. I believe most of you had seen the schedule of the series. So you know the topics that we are going to talk about. Today we are going to talk about one of the most relatively, I will say, neglected till few years ago, but one of the most important from the context of the uninterrupted power supply, the health assessment of the surge arresters. Surge arresters play a very vital role in our power systems, but maybe because they are not very expensive equipment, they remain in a way ignored for long years. But as and when we had taken the cognizance of the failures of the surge arresters, and surge arresters have a tendency of failing violently, there had been the ways and means being worked upon how we can assess the health of the surge arresters. And this particular measurement, third harmonic resistive leakage current measurement, is one of the best ways of doing this measurement almost in a non-intrusive fashion, and most importantly in online condition, without requiring to take any shutdown. on the surge arresters. Today, I have with me my colleague Nilay Ray, who is the head of our product specialist group, and he is going to conduct this particular presentation and many of the subsequent presentations that you will be attending in next 7 days. So, gentlemen, with this, we once again appreciate an absolute overwhelming response from all of you, and we sincerely hope that we will be offering a value to all of you for the time that you are investing with us. Thank you again to Spark Group, Mr. P.K. Patnayak, and I now hand over the dais, or this web dais, I should say, to my colleague Nilay Ray. So, Nilay, over to you, please. Thank you very much. Nilay will be joining us in just a few moments. Please bear with us.
So surge arresters are working as the soldiers that the entry point of the transmission line is saving the expensive equipments like transformers, shunt reactors, and protects them and ensures safety under adverse condition of lightning impulses or at the time of fault. Even
Nilay, just to
yeah.
interrupt. Before you go to the actual presentation, can you just share with us the guidelines that we have to follow when it comes to raising the questions, or how to handle this tool of webinar,
Okay.
please? So that will help all the participants, when especially it comes to the raising of questions.
So everybody, there is one reconnect button you can see at the top of your screen. If you feel any problem on that in your broadcast, so you can click on that reconnect just to get once again refreshed on that. If the entire things gets hanged by any chance due to the internet problem or something like that, our coordinator will refresh the things, so the entire room will go on a reset and all the participants will be taking automatically to a next room, new refreshed room. So that will be automatic. In the right hand side, in the chat button, there are the chat options available. You can put the chats directly to us or on a private basis also. By default, it is coming to send to everyone in the chat mode. You can, after sending the chat, you can also mark it as a question. If you are putting that, the dot you can see beside on the right hand side of your chat, that will be, if you click on that one, that will be marked as a question. So this is in short what are the things what we want to share with you. So nothing other than that is majorly anything is left out. So let me now go to the presentation. So lightning connectors have graduated from the very nascent days, from the spark plug sort of a thing, to that one to silicon carbide, and nowadays it is zinc oxide chemistry. In last few decades, this thing has got a facelift or the technological lift one after another. Though ZNO or the zinc oxide has a superior protection characteristics with respect to the older generation silicon carbide or other chemical components or the air gap things, but this zinc oxide is also having a very bad nature or the tendency to fail violently if the decay or the loss of ZNO is happening. The ZNO arrestor, though not very expensive by itself, but it used to cause a large damage to the adjoining equipment if it is failing, because ZNO blocks failing or the surge arrestor failing is nothing but the blasting of the surge arrestor. So what happens if the equipment is blasting, the part of that same is going to damage the neighboring equipments like transformer or breaker or CT, PT or CVT, all other things. And we can have a very loss of productive items, a very good loss, and non-availability of the equipment, other equipment. So ultimately we will be facing for a commercial implications. Now coming to the surge arrestor ratings. Generally, the 765 kV surge arrestors up to 765 kV surge arrestor are widely manufactured in India. Though there are some companies, they have started manufacturing even the 1200 kV LAs also. Now, LA rated voltage is considered as the 110% of peak phase voltage. So 110% of peak phase voltage means system voltage divided by root 3. We will be getting the peak voltage and multiplied by root 2. Then we will be getting the peak voltage. So system voltage divided by root 3 multiplied by root 2. multiplied by 1.1 is the LA rated voltage. So if we see for a system voltage of 1200 kV, we will be getting a rated voltage of around 1078 kV. For 765 kV, it will be around 690 kV. For 400 kV, it will be around 360 kV. For 220 kV, it will be around 198 kV. For 110 kV, it will be around 99 kV, and so on. Now coming to the construction. Now, as we can see over here, this is the cross section of LA. Here it is marked as the line terminal. So here through this one, we are directly connecting the LA to the line. Then we are having the upper flange and the porcelain tube, as we can see, the outer section, cross section. And at the bottom, we will be having the base plate and bottom flange. In between this porcelain part, first we will be having the FRP tube for the insulation. Then inside that FRP tube, there will be the ZNO blocks, zinc oxide blocks will be available. Now, depending upon the construction, rating and design of the OEM, there could be a FRP rod at the center of the construction, or it may not be there. Like these are the ZNO blocks. If we are having using this type of a ZNO block, then there will be a FRP tube at the center, and there will be another FRP tube at the outer surface. Then outside that one, there will be the porcelain chamber. But for these sort of things, there won't be any option of putting the rod, FRP rod, at the center. And then at the bottom, from the base plate, there will be the direct earthing strip will be going to the earthing. While in between going to the earthing, we can see this surge counter. This is the surge counter. Along with that, there will be one leakage current meter commonly installed in all the LAs. Now, why this degradation used to take place? The degradation used to take place due to various reasons. Majority of them are lightning impulse, entry of moisture, absorption of moisture in the zinc oxide blocks, and other environmental contaminations. And finally, we will be getting the end result as decrease of effective resistance, because the LA is supposed to act as a pure resistor in the healthy situation, and beyond the healthy situation means when the power system is following some high voltage surges are coming, at that time there we can expect a total conductance, or it should be totally conductive part, so that the high voltage goes to the earth directly. So when the degradation starts, the effective resistance in the healthy condition is decreasing. So we can understand, if the resistance is decreasing, then the leakage current will through the LA will be increasing, because there is a live circuit or the live connection at the top, and at the bottom we are having the grounding. So there is a path available. So the leakage current, whatever will be flowing, it will be increasing, and as a result of the same, we will be getting the higher IR square loss, or there will be a lot of heat generation in the LA, and it will go for the failure. So as I was telling earlier, surge arrestor are supposed to be a pure insulator in the normal condition, and it is supposed to be a conductor in case of a high voltage beyond the rated voltage. So we can consider the construction of LA as a single line diagram like this with a diode back to back in configuration. When the high voltage will be there, it will conduct. In the normal condition, it will not be conducting. But there is no material available across the globe which is a pure conductor or which can be considered as a pure resistor. So nothing is pure in this world, in the practical zone. Whereas for LA, we are expecting in the normal condition, it should be a pure resistor, and in the abnormal condition of high voltage, it should be a pure conductor. So two extremities we are talking. So we can consider that there will be a source at the top or the high voltage available at the top, and point number 2 is the connection to the ground. Before going to there, we are having the current measurement or the leakage surge counter along with the surge current meter or LA current meter, leakage current meter. Now if we consider about the current flow, the current leakage current should flow from point 1 to point 2 due to the condition of the LA, where because LA is not a pure thing. Now if we consider a equivalent circuit, so we can consider the LA as a equivalent circuit, a resistance and a capacitance in parallel. So in the capacitive part, there will be the capacitive current, and in the resistive part, there will be the resistive current flowing through them. So in totality, the IT will be the vector summation of IR and IC. So here in the horizontal axis or in the x-axis, we will be taking the voltage, and in the same direction we will be taking the resistive current, because resistive current is in the same direction as that of the voltage, or is in the same phase as that of the voltage phase, and we will be taking the capacitive current in the y-axis, because capacitive current is in 90-degree out of phase as that of voltage. So as the LA is supposed to be purely capacitive, because it is supposed to act as a pure resistor, so it should be a 100% capacitive element. It should act like that. So capacitive current should be large in general, and as it is supposed to be a pure resistor, so the resistive current is supposed to be very small, very small with respect to the capacitive current. So if we want to know how much current or the how much total current is flowing, we should take a vector sum of these two currents, IC and IR, to understand. And this is the total current whatever is flowing through the surge counter meter. To get that I total, I will be taking the vector sum of the same, and I will be getting the resultant as the IT1. Over a period of time, this counter or the leakage current meter will always keep on showing the total current, which is the vector sum of IR and IC. Over a period of time, this IC will practically remain constant because the capacity of the LA is not supposed to change. Practically there won't be any change, or the change whatever will be happening in the IC, that can be practically neglected. But over a period of time, as the LA degrades, the resistive current will keep on increasing. As we can see over here, practically the current has got doubled up till now. Let's say it was earlier 5 count, now it has become 10 counts. So as the IC is practically constant, now the revised total current will be IT2 as shown in the orange color. And after some days, once again the resistive current will increase and the resultant will be coming as IT3. Now practically the resistive current has become threefold. Initially it was 5 count, then it became 10 count, then it became 15 count. So it has practically thrice or 200% increase has taken place. Let's compare how the total current has changed. So we are bringing all the things in the horizontal direction, as we can see in the screen. IC, IT1, IT2 and IT3. These are the currents. Practically there is a very small amount of change, as we can see. Whereas if we compare the IR values in this time period, the same thing, IR has practically become 300% than the earlier initial value. So as IR is very small to that of IC, or the resistive current is very small than the capacitive current, the total current reading shown in the surge counter leakage current meter will be practically showing the value of IC only. Will not be able to understand how much IR has changed, and this reading hence is not that much meaningful, because we are not interested that much on IC, because IC is not a harmful character for the LA. IR is a harmful character. So how we can do the health evaluation? For doing the health evaluation of the thing, we can do the measurement of tan delta, or we can do the measurement of insulation resistance. Now when we are doing the insulation resistance test, we are doing this test as a DC bias. So IC gets ignored because capacitance will not come into picture, and only IR or pure IR is getting reflected during the measurement. But the disadvantage of these two measurements of tan delta and insulation resistance is that surge arrestor need to be taken out of service. So it is cumbersome, and time consuming, because for only LA testing, getting the line shut down is a very tough job in today's scenario, and equipment will be unavailable or the line will be unavailable during this time. So there will be the commercial implications. So the latest technique which is coming into picture in the measurement is third harmonic resistive current measurement, which is recommended by the IC 60099-5. What this number says, though it is a very big document, a lot of people will be having the access to this document, but now this is a snapshot of what it has been told. In the IC guidelines, there are total 8 methods of measurement has been prescribed or described. There are A1 named as A1, A2, A3, A4, and B1, B2, B3, and C2. These are the total 8 measurements, and they have compared these measurements from various angles, the sensitivity and diagnostic efficiency. In the sensitivity, they have considered the harmonics in the voltage, phase shifting, how much it is happening in the voltage or current measurement, how much is the effect of the surface current on the LA, the measurement information, whatever we are getting, how much qualitative information I am getting during the measurement, and finally for the measurement, how much complex it is to do the signal handling, because whatever measurement we are doing, we need to do the signal, we need to measure, so we need to do the signal handling, and finally the service experience. So they have done the thing in medium, high, and low. So here the harmonics in the voltage, when it is low, we will be getting the better result. Hence, it is best or desired or preferred things. When the phase shifting is once again low, it will be a best desired or preferred, because IR is generally in phase with the voltage phase. So phase shifting should be as low as possible. And during this measurement, I want to know the internal condition of the ZNO blocks. So whatever the surface current is happening, the effect of surface current, if it is minimum during the measurement, that should be preferred. So here once again low is preferred. And if during the measurement, whatever the information quality I am getting, if that is high, that is preferable. So in totality, as you can see clearly, in this B2 method, third harmonic with compensation, this is the ideal way of measurement. So that's the reason people are talking about IC 60099-5 method B2 is the most preferred way of measurement, followed by this one B1. There it is only the third harmonic measurement is preferred, and that's the reason we are talking today on the third harmonic measurement. Other methods are used, but it is not that much preferred or not that much popular. Also, you can see over here, these two methods has been mentioned by IC itself as the extensive service experience. And here the C method or A4 method, there is very limited information or no information is available. Though out of that, we are using the voltage peak or the A1 method, we are bound to use in some specific cases, that like GIS application, when we will not be able to use B2 method or B1 method. Now, the point comes how the third harmonic resistive leakage current or the third harmonic thing is coming into picture, or from where the harmonics is getting generated. the IC only or the researchers has came out with the solution or the conclusion that nonlinear voltage versus current characteristics inside the arrestor is the main creator or the it generates the harmonics in the leakage current, because ZNO is supposed to work in as a pure resistor in the normal condition. So it is having a very much non-linear, and we are using the blocks. So non-linear characteristics of voltage versus current inside the LA creates the harmonics. The harmonic content depends on the magnitude of the resistive leakage current. Now, so this is one more finding of the researches. Conclusions. So harmonic content is depends on the magnitude of the resistive leakage current through the LA. This third harmonic, as we know in general, third harmonic is the most significant component among all other harmonics present in the signal. So this third harmonic can be used as an indicator for computing the resistive leakage current and further analysis. This third harmonic component is been found under different technical evaluation or the technical test. It has been found the third harmonic component varies in between 10 to 40% of the resistive leakage current. So why this 10 to 40% and how it is varying? IEC or the researchers has found out why these variance is taking place. These variance is taking place due from manufacturer's design, one of the parameter, manufacturing design. So that is the main or one of the major criteria. Depending upon the design or the construction of the LA, this third harmonic component and resistive leakage current component ratio will vary. It varies as with the temperature, ambient condition, and the moisture concentration also. As as a general practice, a lot of you might have seen that before monsoon and in after monsoon there might be a hell and heaven difference in this measurement reading, because of this zone ambient condition, temperature and moisture of the ambient. Then comes the arrestor rating. Or the surge arrestor rating, so rated voltage of the surge arrestor, and during the measurement whatever is the actual applied voltage. So with the actual applied voltage the ratio is also changing. So we can say from the above equation of 10 to 40%, this third harmonic content, if we multiply it by a ratio of 2.5 to 10, so 2.5 is coming if we are considering 40%, and 10 is coming if we are considering 10%. So this is, if we multiply by this factor, we can get the resistive leakage current of the LA. Now we have mentioned over here, follow anyone as benchmark. That it will be very clear when in the next slide, next couple of slides. However, we need to keep a trend, check the trend, keep a trend of how the resistive leakage current is changing or how the third harmonic current is changing. Like one person is very lean and skinny type of body, his body weight or the structure of the body from the birth itself is very thin and lean. Maybe at the age of when he is reaching to adulthood, he may be weighing 50 kg, but still he is fit and fine. And there could be another child from birth itself, he is having a good stubborn body, and maybe at the age of 18 or 19 he has gained a weight of 75 or 80 even, and he became a bodybuilder or something like that. He is also fit and fine. Now both these guys are fit and fine, but they are not having the So as I was telling, the nonlinear voltage versus current characteristics of arrestor generates the harmonics in leakage current. So how the leakage current is coming into picture, or the how the harmonics are getting generated, that is the first question. So the nonlinear voltage versus current characteristics of arrestor generates the harmonics in leakage current. This harmonic content depends on the magnitude of the resistive leakage current. So harmonic content will increase if the resistive leakage current is increasing. Now these are not our claim. It is the researchers what they have found. Now what we know as a standard thing is the third harmonic is the most significant component out of the all the harmonics, and hence we can use the third harmonic as an indicator for computing the resistive leakage current and for further analysis. Now this third harmonic component, as IC or their researchers has found that it varies, it remains in between 10 to 40% of the resistive leakage current. And this 10 to 40%, how this figure has come? Because it varies with various other parameters like the manufacturing design, the ambient condition, just before the in the sunny day, that wet dry condition, the leakage current value is X, and immediately there is one splash of rain, or the suddenly temperature has gone down, and if we measure immediately after that, we will be getting a totally different value than that of X. So it is thickly associated with the ambient condition, temperature, moisture, everything, earthing condition, everything. Then comes the arrestor rating, whatever is the rated voltage of the arrestor, and at that time of measurement how much actual voltage is applied. Now this applied voltage is nothing but the at the time of measurement, whatever is the voltage available in the system. So in short, this third harmonic current, whatever we are measuring, if we multiply the same by 2.5 to 10, in between a factor between 2.5 to 10, because 2.5 is coming if it is the 40% and 10 is coming as the factor if it is 10%. So I am telling in between a factor of 2.5 to 10, then I will be getting the value of the resistive leakage current. Now the most significant thing we can measure or take care of all these three parameters: ambient condition, arrestor rating, applied voltage. These three things we know at the time of measurement. So what is generally remains unknown is the manufacturer's design, and what is the factor which is coming, which is to be attributed for this design parameter towards this correlation. So if we don't know this parameter, then my measurement will not be complete, and hence we have told follow anyone as benchmark. If you do not know this manufacturing design, forget about it. You follow the third harmonic current itself from day one as a benchmark and follow the trend. Follow the trend. This is the major thing. You have to do the trending. On fine morning, just I am going and checking the value, and I cannot say it is a faulty. I'll give you an example. Like myself as a person, from the very beginning of my childhood, I am a bit overweight kind of thing. Now, does that mean I am a very much sick or something like that? No, because from the birth itself I am having a stubborn nature. Physically I am a stubborn figure. I used to do I used to do the athletics, football, and bodybuilding. All these things I have done. So I am fit and fine with a weight of 80 kg. Now there could be one more person who is very lean and thin. From his childhood itself, his weight has not taken up, and today also in the same age, he is in the zone of 50 kg or something like that. Now, does that mean he is sick? No, he may not be sick, because that could be his nature. Am I overweight? Am I something like sick? No, because I am fit and fine, because that is my nature. So I have to understand the health of the LA. I should know what was the initial value, how the value has changed. Now, for that 50 kg guy, if over a period of 3 months, if he is gaining from 50 kg to 80 kg, and I am gaining, let's say 5 kg, then I may not be having a too much concern. But the person who has reached 80 kg within a period of 1 month or 2 months, I have to be concerned, because there must be something wrong. That's the reason he is gaining the weight just like that, because he has not gained the weight from his birth, and suddenly he is started gaining the weight. There must be something wrong. That we need to understand. So that is the reason we need to check for the trend. Now, how to do the trending? Because here, as we have seen, it varies with the ambient condition, arrestor rating, and applied voltage. So I have to keep a standard value, or that is the IR corrected. Now our product SA30i or SA30i plus, it measures the total leakage current and then calculates the third harmonic current. This third harmonic current is measured at an ambient temperature, and whatever the system voltage available present at that time of testing. So I need to go to a standard value. So leakage current expected to vary at different system voltage and ambient temperature. With trend varying condition, trending may not be accurate. So I must refer to a standard value. IEC has suggested how to do this standardization. They have suggested to convert the measured value to a standard condition for trending. For doing the trending, we have to take the reference of system voltage, LA's rated voltage, and measure temperature to a standard temperature of 20 degrees centigrade. So we need to take the cognizance of applied voltage take it to the what could be the extrapolated value at the rated voltage, and measure the ambient temperature and extrapolate it to the temperature of 20 degree. What could be the value? IEC has given those graphs. IEC standard conversion factors are already programmed in the kit, in our kit. So IR corrected is the automatically calculated or converted value as per the IEC guidelines from measured third harmonic value to reach to the IR means resistive value, and that's the reason it is called as the THRC. People are also calling it as the THRC kit, third harmonic resistive current. So this is the full terminology. Some people are using THRC kit. So it is the third harmonic resistive current kit, and this is the kit which we are having in our kitty. This specific picture, what you can see is the SA30I class, which is the leakage current analyzer for surge arrestor. As we have told, we do not require any shutdown, no online. It is an online kit. Directly the online condition you can do the measurement, so no outage is required. Preventive maintenance of surge arrestor in most efficient manner can be done with this kit. It conforms to the IEC 60099-5 clause 6.3, and there are three methods available inside the kit. Method B1, as I have shown you in the chart in 2 slides back, method B1 is available in the kit. So third harmonic analysis of leakage current, only third harmonic analysis. Method B2, where we are doing the third harmonic analysis with the compensation of 4 harmonics in the system voltage. So system third harmonic measurement with the system harmonic compensation is the method B2. For that one, we require this field probe. And for the third harmonic leakage current measurement, we require this CT, specially designed clamp on meter is required. And in case of some zones where we are not in a position to put this field probe, then we may have to use this A1 method, which is called as the voltage peak method. Though this is an optional feature to this kit, this is not a standard feature by default supplied along with the kit. So as an additional request at the time of purchase, if you are putting this request that voltage peak method is required, then there will be some other accessories will be coming along with the kit, and the same kit will be activated in the software menu with this method A1. Then this kit can be used for A1 method also. So maximum this kit can work on 3 methods. That's the reason that SA33 number has come over there for the to correlate that 3 measurement methods can be catered into. Measurement of I total by a specialized current clamp as shown over here is done. Once this current clamp is measuring the current, then we are doing the third harmonic calculation, third harmonic component available in the measured IT. Then we are doing also taking the system harmonics current through this field probe. Once again the third harmonic component is calculated over there. And then we are doing the estimation of IR as per IEC 60099-5. And then finally, also we are having the inbuilt temperature probe in the instrument. So we are measuring the ambient temperature at the time of measurement of this leakage current. So we can calculate automatically the IR corrected. Instrument will give you the automatically calculated IR corrected value as per the IEC standard factors, whatever they have given. The instrument is also, you can give the input of system voltage and relay LA rated voltage. So system will, this instrument will automatically calculate the all the factors except only one factor, that is the manufacturer's design. Due to that, how much percentage or the percentage ratio between third harmonic and resistive leakage, that factoring is not possible automatically. Other things, other three parameters, the ambient condition, that is the temperature, rated voltage, that you can give as the physical input to the kit, and system voltage at the time of measurement, that also you can give as an input to the kit. So once you are giving all these three parameters, then the instrument will calculate the IR as per these factors given. And then the remaining factor, to address the remaining factor of manufacturer's design, we have given a factor of 1 to 10 that you can put physically on the instrument. You can select that factoring and you can go for the actual resistive current measurement. In absence of the Williams factor, you can consider the third harmonic value only as a benchmark and you can keep a trend of the same. Now connection to the DUT is very simple. The LA you need not have to take offline, but the measurement we need to take some precautions. The CT unit, as we can show over here, see over here, it has to be connected in between the LA base and in the earthing strip, but before the LA counter, as we can see over here, before the LA counter we need to keep this CT unit to get the proper result. If we are taking after this, the result varies a lot. So you must be very careful to put or to hang this CT unit in between the LA base plate and before the LA surge counter. The field probe unit with the FRP rod is supplied by default with the FRP rod that as per the your ordering, whether it is for 400 kV or 220 kV or 765 kV, we are giving the appropriate length of rod and accordingly. But still the thing is that this field probe top must not be taken at any condition beyond the LA base. That is the very much precaution anybody during the test must be taken. Otherwise, due to the presence of the live line, and here we are having a field probe unit which is having the metallic structure, so there could be a flashover in between them, though the FRP rod will save the person, by instrument can get damaged. Now this CT unit and field probe unit are having equipped with the wireless sensors, so it will be measuring all the data, both they of them separately, and they will wirelessly send it to this unit, the base unit. Now here, as we can see, as I was telling, this field probe unit must not be taken beyond the base of the LA. You can keep a little bit lower than LA base, no problem, but it must not be crossing this base height. Base level I must not cross at any condition. So this is the instrument, very simple to connection and very simple to operate. There are the other features available in the kit, which like USB port, trending of the data, software is by default provided. You can take the printout of the result on the site itself and so on. Other features. For other details of the kit, you can contact us in your marketing ID, marketing@scopetnm.com. In that email ID, you can contact our sales team for the details of the kit or for the demonstration of the kit at your premises. that can be done. Now, coming to the very fag end of the session, how to identify the faulty arrestor. As I have told you earlier, the trending has to be noticed. So if the value of the arrestor, that third harmonic current value is from the day one of the LA is, let's say, 80 microamps or 90 microamps. So you are happy. You keep on checking whether it is changing or not. But the moment it starts changing, you have to be more cautious, because when it starts deteriorating, it deteriorates very fast. So you have to be more vigilant when the result is showing the increasing nature, because simple one value cannot or may not be the determinant for your LA health. So you have to see it for a trend. And once it is showing the increasing trend, it should be tested on a very regular basis. Maybe you can test it once in a week or once in 15 days or max once in a month, because once in a month also could be a very big time, because the once it has degradation has started, it can fail violently. Now, generally all the people used to ask the what should be the limit. Being the, as I have told, being the manufacturer of the testing instrument, or as told you earlier, there nobody can say the correct limit. Like I have given the example of mine and one of my friend. I am weighing generally a higher side. He is generally weighing 50 kg or in the lower side. Now, as per the WHO standard or the national standard, there are some limits. Like generally, healthy human could be weighing 5.5 feet long, or it is the standard height of Indian scenario. 5.5 is the average height, and average weight is 65 kg plus minus something, or 70 kg something, like plus minus. So similarly, the limits of third harmonic current will differ with make and model, design, construction, and rating of the LA. So here we cannot say any specific value, but there are, and IC has also not specified any value as such. They have also talked about the trending of the data, but some of the utilities are following some data, and obviously who is the best person to specify this limit is the LA manufacturer, because they know their construction, they know what kind of ZNO blocks they are using, what are their characteristics. So they are the best person to specify you the values. So you ask in the test report of the LA manufacturers, specify the limits. You mention the resistive current as well as the third harmonic percentage during your test report. It must be mentioned, and your factor must be mentioned, and what should be the value at which it should be taken out. Like you know that breaker timing, what is the safe operating zone, operating time of the breaker, like what should be the closing time of the breaker, what should be the tripping time of the breaker. That is not told by the instrument manufacturer who are measuring the timing of the breaker. Those kits are not giving, those manufacturers are not giving those values. You are asking those values to the breaker manufacturer. Similarly, over here, it's better to ask the LA manufacturer only to ask for that values. However, the all the utility peoples are available over here today in this platform, and they are having their vast knowledge, and based on that knowledge they have come up with some of the values. So we are showing you these values, but This is the experience of various utilities. This is the average they have taken as per their experience. So we cannot tell this as the standard value. It is the maximum utilities are following. It is just a data piece of information we are having, we are sharing with that. So nothing we can say that it may happen that you should not ask tomorrow that sir it is my 60 my LA has blasted. So we cannot say. Have said this limit 150 microampere and above, they are keeping it the LA for close monitoring. More than 50 microampere, they are taking out the LA for the maintenance. And if required, they are replacing the same. So either should get the limit values from the manufacturer or you set your own limit, your standard. As you are having the standard operating procedure in your organization, so follow that standard. So whatever standard your organization is fixing, follow that standard. Whatever the LA manufacturer is telling, follow that standard. This is just a reference scale, nothing else. So with this, from my side, I am done. Now I will take few of the questions with my colleague, Mr. Arithro.
Nilay, I had seen some questions.
Yeah.
So maybe we can take some of them. So I'll just take them one by one as I had seen them. There is a question asked by Mr. Mohit Gupta. He asks that please explain about IR and IC. So Mohit, as far as the IR and IC is concerned, as the name suggests, IR is the resistive current and IC is the capacitive current. And when we talk about the total leakage current from the surge arrestor, which is going to the earth from the base of the surge arrestor, the total leakage current is the one that we capture by using clamp on meter. So what we measure there is the total leakage current, and there are two components into that. The first is capacitive current, which is a dominant component into that, which is 90 degrees phase shifted with respect to voltage. And there is another component which is the resistive current, which is in phase with the voltage. And since it is in phase with the voltage, that becomes more important and more dangerous, because since it is in phase with the voltage, you get the I square R heat losses happening inside the surge arrestor, and then that eventually cascades into a failure of the surge arrestors. So I believe it's now clear what is the difference between IC and the IR. So this was one question. The next question is coming from Rohan Tamhankar. Difference between compensation and without compensation, that is B2 and B1. Rohan, the term compensation here means the measurement method is based on third harmonic component. And here, when we put the clamp on a conductor which is running from base of the LA to earth via surge counter, what we are eventually capturing there are two components. First component is a third harmonic resistive leakage current, which is generated because of the deterioration or the nonlinear characteristics of the surge arrestor. But since we are capturing this third harmonic component, there is another third harmonic component which is also flowing in that path. And that component is the third harmonic component which is already present in the system voltage. So that particular component which is present in the system voltage is not what we are looking at, but that also eventually gets added into the clamp, rather into the total current that we are measuring by using a clamp. So we need to have some mechanism by which we can distinguish or identify this third harmonic component in system voltage and we can eliminate that. And for that, we use the accessory called as field probe. There is another question related to field probe asked by a gentleman. I will answer that here itself. So field probe is an accessory which is kept at the base of the surge arrestor, which forms a capacitive coupling with respect to your conductor, a live conductor. And through that capacitive coupling, we are measuring a voltage signal, and from that we are identifying the third harmonic component in that voltage signal. And this component is then compensated in a particular manner. So that is basically what compensation, the term compensation is used for. So this is what we talk about, the compensation or without compensation, and those two respective methods, B2 and B1. I hope I had adequately answered this question, Rohan. The next question comes from Shailendra Chauhan. How third harmonic is most significant as far as the LA is concerned? Now, this is a study which is done by the IEC, and IEC standard mentions that your resistive leakage current, if you want to measure if you measure the harmonics, in that case, larger is your resistive leakage current, larger is the component of the third harmonic. So there is a correlation between resistive leakage current and third harmonic component. So this is, adequately mentioned in the standard. So that comes from the standard. The next question comes from Sita Ratna Kumar. What is the limit of resistive current as per IEC? So Nilay has already touched that particular part at the end of the conversation, that what are the limits. Essentially, they should come from the manufacturer. The next question is, what happens to resultant value after measurement if the system voltage itself is having harmonic content? Now, as I explained a while back when I was talking about compensation, if your system voltage is having large third harmonic component, then naturally that is going to get captured when we measure the total leakage current. But the measuring devices like the SA30i or SA30i Plus that we talked about, they have a capability of identifying the third harmonic component in system voltage and compensate for that, so that eventually what we get is what we are looking at, that is the third harmonic component which is generated because of the deterioration of the surge arrestor. So this is the answer to this question. Next question is already answered. It was from Satyanarayana. What is the difference between B1 and B2? So we talked about that. There is one more question from Shubhankar Brahmbhat. It is, what should be the exact position of the field probe? Now, as far as the positioning of the field probe is concerned, the recommended position is that we raise the field probe plate till the base of the surge arrestor, and generally you keep it just below the line, just below the conductor. So that is the best position as far as keeping the field probe is concerned. Next question is from Arvind. Does the instrument having any harmonic content filter for the input supply of the test kit? Actually, the kit operates on the battery, so it uses the AC supply just to charge the battery. So that particular harmonic, which at all is coming on the input side, is not getting mixed with the measurement signal. The measurement channels are totally isolated. So anyway, even if the kit was operating only on single phase AC, still in that case, there wouldn't have been a mix-up of a signal. So there should not be any concern with respect to this. Another question from Naresh Guram. Could you please elaborate how the kit distinguish system voltage harmonics with leakage current harmonics? I think this also we touched. The field probe is an accessory which is used for understanding the harmonics in the system voltage. So you can imagine it in this way, that there are two isolated measurement channels. One channel is taking the input from CT, and the other channel is taking the input from the field probe. And they are both taken on a common time scale. So that is how the kit or the system is able to distinguish between the system voltage, the harmonics in the system voltage, and the harmonics in the current, leakage current that we are trying to measure. So these are these precautions are well taken when the kit is designed. There was one question, very relevant question from Mr. Ajay Kumar Jetwa. He asks, as our system, the LA base plate to earth chamber connection is through a 50 mm by 6 mm earthing strip. Is it possible to use the said CT? You are right, sir, because you might see that the clamp that was shown in a picture is having a clamp opening of around 35 to 40 mm, but we do have a larger clamp as well, which can accommodate 55 mm object. So for a flat which is 50 by 6 mm, we do have a separate clamp which can be used, and you can still carry out the measurement. So it's not a problem at all. Next question from Badal Patnaik. What does field probe unit measure or record? The field probe, basically, as I said, field probe is kept at the base of the surge arrestor. It creates a capacitor with respect to the conductor which is on the top, air being a dielectric medium, and through the capacitive coupling, the signal, typically a voltage signal, is measured, and then the harmonic components from that are identified and compensated for. There was one more question from Sambasiv Rao. What is DUT? DUT is a very common term used to define device under test. Like when you talk about the LCM, surge arrestor is a device under test. If you talk about breaker analyzer or DCRM, then circuit breaker is a device under test. So I hope that's clear. There was one again important question from the user perspective. Mr. Jitendra Nabin Chandra had asked, third harmonic component is around 10% to 40% of the leakage current. But which side is better? Whether we should take it 10% or we should take it 40%? So, sir, basically this itself will change from the design of the LA to the design of the LA. So for different LAs, these factors will be different. So that's why what Nilay was suggesting about the trend analysis, that matters more. So it cannot be said that, whether it will be 10% or 4% across the board. And that's why when we were designing our kit, we had a very close interactions with some of the utilities, especially with Power Grid. And they told us that since this component is variable, you please don't any fixed multiplication factor in your instrument. In some of the instruments which are available from the manufacturers abroad, they are somehow considering this factor to be 25%, and they are putting a multiplication factor of 4. So that means we are assuming that this factor is 25%, which is not true. So that's why we had kept this particular factor deliberately and very consciously settable for the user. You can set it from anywhere between 1 to 99. But if you really want to identify which factor you should set, you need to get data from the LA manufacturer. And then for a particular LA, you can set this factor in a software of the instrument. And once you select that type of a LA, automatically that factor will be mapped or attached to that. But till that time, what is recommended is that instead of going for this multiplication factor to convert this third harmonic component into a resistive current, you can jolly well monitor the third harmonic component itself by keeping this multiplication factor as 1, because eventually we are looking at a trend. I think these were some of the questions. Maybe Nilay, there are more questions, we can take them.
Yeah, where you have already covered the majority of the questions. There are some other questions there, but hopefully we have, by and large, you have covered all those questions. Couple of questions I could see, like the accuracy of measurement. This accuracy of measurement which we are claiming in our kit is plus minus 5%. Now, you can ask if plus minus 5% is too much, a very big band, but depending, if you look into the measurement values that we are measuring into the microampere and in the vicinity of a charge switchyard, where 400 kV or 765 kV even, in that zone, the leakage current itself in the induction, it will be very high. So that's the, to get that measurement of microamperes faithfully, we are not being able to reach more than that. And generally people, even IEC has also told k plus minus 10% is also okay, because here we are not looking forward for the absolute values. Here we are once again looking for the trend. So practically when it is 5% of 100, so it is only 105 or 95. So based on the value of 95 or 105, nobody is going to take any conclusive decision that when it is 95, my LA is healthy, and the moment it is crossing 100, it is unhealthy. It is not like that. It is a trend we have to look forward for. Hence, that 5% is generally acceptable by the industry and all other manufacturers. So whoever is having only one practically, they are also giving the same accuracy in this measurement. As you showed in the beginning, calculation of rating of LA, please, for example, of 400 kV systems, have in some days our 330 kV LA for how it is possible. So it is this 330 kV and other things, whatever you are talking, that is the during the measurement, whatever the system designing. This is Mr. Anil Verma has asked, in 400 kV we have done shown the calculation of 360 kV, and in their system some of the LAs available in 330 kV or so. How it is possible? So that's the reason I am talking. It is the thumb rule calculation I have shown you over there. Whatever is the theoretical value, but theory and practical, it is totally different. So when we are designing our substation or our actual electrical system, we are doing the substation designing. That is a big subject is available, and based on your system and other things, we need to do the calculation and how much safety factor we are putting based on that. So even if I remove that additional 10%, so it will be 330 kV, because I have taken 110%. So if I don't take that 110%, so it will be coming 330 kV. So additional 100%, 10%, whatever I have taken, if we don't take that 100 additional 10% in your design, so it will be 330. So my value and your value are matching.
There is a question asked by a couple of people, what is the cost of the instrument? So I think it may not be appropriate to share the cost on this platform. We request you to just drop us an email on marketing@scopetnm.com and we will get back to you with the prices, sir.
Mr. Chandrakant Patel has asked, how can we measure the GIS LA, third harmonic current? Sir, for this one, as I have told, we have to go for the voltage peak method, which is available as an option to our basic kit. So we can supply you the same. So through the voltage peak method, we can go for the third harmonic measurement.
There is one question asked by Mr. Wahid. He is asking the comparison between LCM 300 and SA30i plus. I believe he meant to say LCM 500 probably of Doble. So as far as the comparison is concerned, I mean the more or less the things are similar. But few improvements that we had done after taking the feedback from the customers are like this. I spoke about the multiplication factor. So I believe there they had kept the multiplication factor as fixed of 4, assuming that the ratio of the third harmonic component and the resistive current is 25%. So since IC says that it is between 10 to 40%, we had kept it user settable. So that is one important difference. There you by default get IR as THRC multiplied by 4. Utilities like power grid, they manually divide by 4 and make the record of that particular reading. So there was a specific feedback that we must not do it. So we had not done it, and we had by default we show it as a third harmonic component. And if you want to compare the results with LCM 500, you can set that multiplication factor to 4 so that you have a comparable results. This is one thing. Other thing is, I believe we give the built-in printer, which is not available there. So in case you want to have a hard copy as evidence or as a ready printout of the results, that is additional thing which is available in SA30i. Of course, the couple of important things are related to the ruggedness of the product, because the conditions in India and the conditions abroad can be different. So our kit is ruggedized for the Indian conditions, and since it is indigenously designed, developed, and manufactured by Scope, the complete technical control is with us. All kind of after-sales service support and technical support is in our control, which we provide very promptly. And of course, I mean, you all at one point of the time or other had used the Scope instrument, so you know about the service support of Scope. So I think these are some of the distinguishing factors. We had also come up with an online kind of a surge arrestor monitor, which is maybe in years to come, that will be a future where there will be permanently installed online monitors. So we are working on all kind of associated measurements as far as this LCM is concerned. So that's what I can say about the comparison part.
There are several questions. So one question I am combining a few people like Mr. Ranjit Panigrahi, Mr. Chandra Bhan Kushwa, Mr. Jay Patel, and some of the other peoples. The things what they have asked, I am answering in detail. So the things were that why third harmonic only. Number one is that first basic concern is that in the any signal, as we know the very basics, the third harmonic is the most significant component in any of the disturbed signal. So that's the reason we are not taking the fifth or seventh or any other harmonic. Third harmonic is the most significant. So we will be getting the maximum amount in third harmonic analysis only. So one of the person has asked how the calculation is done. So it is the third harmonic calculation. There are various methods available in the engineering or the design or in the mathematics. So either of the things has been developed, though being the design manufacturing secret, you can say you can implement any of the same, and either of these things only has been implemented. So there is no new method to analyze how much is the third harmonic that we are doing. So it is the mathematical calculation, only the mathematical formulas has been used.
Mr. Anil Kopkar had asked the question, what is the expected life of the instrument? So, sir, in this context, I mean, as far as the Scope products are concerned, the instruments that we have sold even 15 years back, 20 years back are still in service, and we are providing them the after-sales service and calibration support. In fact, that is one factor which one of our marketing consultant told, that your instrument should not last so long. You are not getting any repeat business. But when it comes to typically, if I were to answer your question, you can take it for granted that at least the 10-year will be the expected life of the instrument, because especially in current times, the technology is changing so rapidly that after 10 years, the instrument may lose its relevance and something new will come. So this is what I can respond to, sir, as far as your question is concerned.
I think we have practically covered the majority of the questions, and if somebody has asked any questions and his question has got lost in the flow by us, we will try to accumulate all the questions and we will be putting it into our blog as well as into our, we can circulate it to your email ID as an FAQ of all the questions.
So very good. So I will take a final question. There is a question from Hemendra Sisodia, and he's asking, how can I know if the kit is calibrated? Actually, sir, I would like to tell about one feature of this particular instrument. In this instrument, there is a functional check facility. That means essentially what we measure in this instrument is a signal of 50 hertz component and a signal of 150 hertz component. So there is a built-in signal generator inside the instrument which generates a standard signal of 50 hertz and 150 hertz, and that is sent out. So you can simply connect your CT to this functional check or the calibration check kind of a terminal that we have on an instrument, and you can verify because that instrument is going to send out a standard value, and you can measure back that standard value into the measurement channels, and that is how we can very quickly and very effectively measure or rather assess that the instrument is working okay. But of course this is not a calibration check, this is more of a functional check. And before you go and actually set up your instruments in a switch yard, you can have this quick check in a lab or in your office. So that helps you. As far as calibration part is concerned, like most of the instruments that we are offering from Scope, we had developed the portable calibrators, which are in turn calibrated in Enable accredited labs. And we come to the site and we do the calibration of our instruments on site. So majority of the instruments, we do the calibration on site and we give you the calibration certificate. We affix a sticker which gives you the calibration validity. So from that sticker, you can understand what is the validity of the calibration. And as far as you want to assess whether my instrument is working well or not, in this particular instrument, there is a fantastic facility of functional check, which I strongly recommend that each one of you can use. So I believe with this, we will close the question and answer session. This has been a wonderful experience for us. This is the first of the sessions of the 7 sessions that we had planned. Today there had been few technical glitches, but I think as we move forward, these will be, these will be taken care of, and we will become accustomed to this particular tool of the webinar that we are using. So, ladies and gentlemen, thank you very much once again for taking out the time, spending your time with us and allowing us to share whatever little bit of a knowledge that we had about this measurement with all of you. In India especially, we had not really built a community where we can do a collaborative work. Like we are a manufacturer of a testing instrument and many of you are the users. Where we lag nowadays is, there is no collaborative effort between both of us where we can come up with, many more simple solutions for the difficult measurements. This used to happen more earlier, but now this is one thing which is missing. But I think with the platform like Spark, we had got this opportunity and a mechanism where we can come back, we can deliberate on a topic, we can collaborate on a topic. Many times we will be requiring a help from your side because we keep on continuously improving our instruments. And all these instruments are to be used in a 400 kV, 765 kV substation. So we can't simulate these conditions in our laboratory, in our R&D. So we need to test each and everything on field, on a test object. in a 400 kV or 765 kV substation. So that is the area where we are looking at a cooperation from your side, so that more and more field trials we do. Eventually, when you get the instrument for usage, there is zero failure in the instrument. So with this one appeal, I close this particular session. Thank you very much, and we'll meet again tomorrow at 4 o'clock. Have a good day.
Before closing, a lot of people are asking the PPT and other things. So we can tell you that this entire recording will be available on air, and we can share you the link also if possible, though, or we'll try to upload this entire session to YouTube or something like that, where from you can get the details. And see you, and with your blessings we sign off for today, and see you tomorrow once again with your blessing.